gravity separator is designed to separate by bulk density. The principle of gravity separation is usable on any dry particle stream. Essentially, you're feeding particles to the upper end of the deck. We're fluidizing those particles by blowing air up through them. We've got pressurized air created underneath the machine coming up through the particles. They're weighing themselves as they hit this portion of the deck, from heavy on the bottom to light on top. The product flows this way. We've got a perpendicular eccentric motion that is tilted uphill. That drives the heavy product in contact with the overcover up. It allows the light product to flow over the top and consolidate here on the light rail. This particular machine is doing a very nice job of taking out a very light contaminant, and also, as you can see at the top end of the deck, a very heavy, gritty contaminant, all separated from a very good particle flow in the middle. This separation is basically allowed by an adjustment of 5 different things on this deck. 3 of them are going to affect the quality of the separation. Those 3 things are the airflow up through the product stream, the eccentric motion of the deck, and also the side tilt of that deck. As far as the other 2, they are basically built around capacity, and they're end rays of this particular deck, and also the feed rate that you see here. Automation is key in the fact that it simplifies the operation of this machine, and it also allows you to save a setting and return to it later this afternoon or maybe next year. If you look at something in this situation where you create too much air, as in this case, you'll see your separation goes to pot. We've got heavy material coming down into our light material. I can adjust that very simply by going back to the same air setting I had previously. You'll see the heavy product sink back to the deck and move back uphill and react as a heavy particle. The other aspect of quality can be affected by the amount of side tilt that we put on this deck. If I shut the side tilt down to a relatively low angle, you'll see that we lose consolidation of our light product here, and we start to get contaminant back into the good material. As the side tilt is again angled up, the heavy particles will start to come back down and give us a nice even depth of bed across the machine this way, and our light product again starts to consolidate against the rail where we can discharge the contaminant. The other aspect of quality separation is the control of our eccentric speed. If I slow down the eccentric speed by quite a bit, you'll see that we're not driving the heavy material up to the high end of the deck anymore. It's allowed to flow back down, and you have this problem as we see up there. That heavy contaminant is no longer consolidated against the high rail on the machine. That can be very easily adjusted by, again, increasing the amount of eccentric speed and pushing the heavy material back to a consolidated point along that rail. And again, we come nearer to having our better separation.